Yes, class. Am I audible to all of you?
Yes, ma'am.
All right.
Yes, ma'am.
Sidra, Harsha, Rishita all have joined. Mariam. All right. Yahya is just absent today. All right. See, so I think your class timings have been changed. Tuesday and Thursdays now you will be having your classes. So that's why we are having class today. Then we'll have the class on Tuesday. So Tuesday and Thursday itself. So yes, let us see what all we have studied in the last class. Electric charge, methods of charging. You had charging by friction. There, what was the important thing you have to remember? By whichever material has the stronger bond, that becomes positively charged, right? This is the technique that you have to remember. Then you have charging by conduction, where both the bodies weren't rubbed against each other. They were just placed in contact with each other. So when they were placed in contact with each other, the transfer of electrons occurred, right? And if the bodies are identical, then the charge distribution becomes equal. That is, whatever charge is being distributed between the two bodies will be received equally by both the bodies. So this was an important concept that will be used. Charging by induction. See, in charging by induction, you do not have the contact force available, right? What do you have in charging by friction? In charging by induction? In charging by induction, you just temporarily electrify the object. That is, you separate the charges without actually bringing them in contact with each other. Then we have seen the properties of charges. Yes. So what are the properties of charges? Additive nature of charges. Charges are added. Conservative nature of charges. Charges are not created. They are not destroyed. They are just transferred from one form to another. And then this is the most one is the invariance of charge. Invariance of charge means that you have the charges at the same speed and all the objects. Even if the speed increases, your charge will be the same. Then you have quantization of charge, which is the most important out of all of these. So quantization of charge means that charges are integral multiple of what? The term 1.6, the number, actually the electronic charge 1.6 into 10 to the power minus 19 Coulomb. In the next class on Tuesday, whatever topic we'll complete till today, Coulomb's law also we'll start that, and the entire introduction of the electric charge. You have to revise. I'll not be taking a test. I'll be just asking you questions before the starting of the class. All right, before we start with the class, I'll be asking you questions. So just you have a lot of time till Tuesday. We'll be studying with, we'll start with Coulomb's law also. So that also you can add. Yes, this says that calculate number of electrons corresponding to 1 Coulomb. Means charge is given as 1 Coulomb. Number of electrons you have to find. Electronic charge, we know it's 1.6 into 10 to the power minus 19 Coulomb. I have repeated this electronic charge so many times in the 2 classes, and this is the 3rd class. This I will be asking and telling, so you should remember. Please. So what is the charge? Charge is equal to Q is equal to NE. We have to find N. So what N will be equal to? N will be equal to charge divided by the electronic charge. What is the value of charge given? Charge is given as 1 Coulomb. What is electronic charge's value? 1.6 into 10 to the power minus 19. Now, what is number of electrons? This will be 6.25. This is 6.25 into 10 to the power positive 18. Now, see, in most of the questions that you will be facing, you will get sometime a situation where you have 1 over 1.6 into 10 to the power minus 19. So I would suggest this answer you should remember also. All right, this answer, I think it will be helpful for you if you remember this. One good question you have from your NCERT back exercise only, which involves the concept of your chemistry. Only, I'm telling you right now only, write down this question with the solution, then write down this question too and try this first yourself. One thing I'm giving you a hint, you have to use the concept, mole concept, which you have studied in your class 11th chemistry. All right, because number of electrons, Avogadro's number, all these things you have already done. So that is only be used. All right. Write down these two. Then we will discuss this last. This is the last question. Then I'll be starting with Coulomb's law. Let us discuss the question also. Sufficient time was given now. See, why I said you have to involve the concept of your 11th class chemistry is that you have to calculate number of electrons in 1 glass of water. And we say that in 1 glass of water, if just 1 glass of water is mentioned to you, take it as 250 centimeter cube, because 1 glass of water, with that information, you will not be able to solve your question, right? You have to have the information about what is the volume when we are referring to 1 glass of water, right? So here the volume that we are referring, volume is 250 centimeter cube. And one thing that in class 11th also I was telling you, one thing you have to remember is the density of water. Density of water will not be mentioned to you in the questions in the exam, but it will be used in the numericals directly. So this is density of water when you will use this density of water. This is 1 gram per centimeter cube, right? This is 1 gram per centimeter cube. Now, if we have volume, we have density. One thing we can calculate, that is the mass, right? We can calculate the mass also if we have the volume and density. What is the relation between all these three? Density.
Mass by volume.
Correct. Very easy. Density is equal to mass by volume. So look, density is equal to mass by volume. So from here, one thing this implies that mass is equal to density into volume, right? Mass is equal to density to volume. So density is 1, volume is 250 centimeter cube. This is gram per centimeter. Centimeter cube cancels. So mass becomes your 250 grams. All right, you have the mass as 250 grams. Now comes your concept of class 11th, moles concept. What is moles concept? How we'll be using the mole concept? That we have to find out number of moles. So in 250 grams. So how do we calculate? We take the mass. This is the only formula that we use. We take the mass and divide it by the gram molecular mass. Mass is given as 250. What is the gram molecular weight of water?
18.
18. 18. Very good. This is 18 moles. So this much data we have. Now, if we have to calculate the number of molecules in one, we'll be calculating the number of molecules. Number of molecules in 1 mole. So whatever is the number of moles, just multiply it with the Avogadro's number. So number of moles is 250 divided by 18. This is the number of moles. Multiply it with the Avogadro's number. That gives you number of molecules, and that's how we calculate it. So this will be into 6.022 into 10 to the power 23. What is this? This is your Na, Avogadro's number, right? So this will be, I think, 8.3. I have not calculated this. This should come out to be 8.3 into 10 to the power 23. Right, just confirm it once. While you are writing, or just calculate and confirm it once. This is what I remember the data. Now see, when we are talking about the number of electrons, because we do not have to find out number of molecules in this. We specifically have to find out the number of electrons, right? So number of electrons when we are calculating. So in water, we are calculating H2O. For oxygen, it's 8, 1 each for water, right? So that becomes +1, +1, that becomes 10 electrons. So these many electrons are present in 1 molecule of H2O, that is water, correct? So we have to find out what if one molecule has 10 electrons. So this much molecules, these many molecules will have how many electrons? Clear? One molecule of water has 10 electrons. These many molecules we have calculated. So these many molecules will have how much amount of water, right? So simply you will multiply same amount with 10 to the power 24 will come. So number of electrons in Na molecules. Na molecules means this, Avogadro's. In fact, it's not Avogadro. Let's write the complete data.
Ma'am, how is it 10?
Yes,
How is it 10 electrons?
10 electrons.
How is it?
You're asking about this, Maria.
Yeah.
10 electrons for water. See, for oxygen, oxygen has 8. 1 hydrogen plus 1 more hydrogen. So 8 plus 1 plus 1. So same amount of electrons.
Oh, okay.
So number of electrons in 8.3 into 10 to the power 23 molecules of water will be equal to the entire value multiplied to 10. That will be 8.3 into 10 to the power 24 electrons, like this. Right? So entirely your chemistry's concept of class 11th also is revised now. Write this down, solution. Then I'll start straight away now with Coulomb's law. Again, I'm repeating, on Tuesday, before we start with the class, I'll be asking you questions from this as well as whatever we'll complete in Coulomb's law.
Ma'am, could you explain the question from our homework? How much positive and negative charge is there in a cup of water?
Done? All of you?
Yes.
Others also?
Yes.
Yes, ma'am.
All right. All have completed. Then let me start with Coulomb's law. See, what is meant by Coulomb's law? I told you in the last class also that if you study your gravitation portion, then this will be helpful in your Coulomb's law, understanding of your Coulomb's law. And those students who were with me last year when we were doing gravitation, that time also I told you that immediately in class 11th, your 12th, your first chapter will have something related to your gravitational law. This law is very similar to that law. I told you also to revise it. So since this class is arranged suddenly, even I was not aware, so I'm not asking you. But please revise your gravitation's Newton's law, universal constant law. Now see what is meant by Coulomb's law. Two charges are present, right? Plus Q1 minus Q2. All these charges are present. So one property that we have been discussing is that if both the charges are having opposite signs, that is one is having positive, other is having negative. So what will happen? They'll move towards each other. Why? Because of forces of attraction. And if the same thing is there, but the charges have the same signs, so positive or negative and negative, both will be repelling each other with full force, right? Now, Coulomb's law helps us to find out if both the charges are present, they are attracting, they are repelling, what is the exact magnitude? Like we can say 5 Newton of forces between both the charges, 3 Newtons of forces between both the charges. At least what is the magnitude of that force? So that magnitude of the force, this is calculated through the Coulomb's law. All right. So Coulomb's law basically says that, so this magnitude, direction is something different. Though charges are scalar quantities, so we know what type of directions do they have. The directions that they possess, the charges, it's just that attraction or repulsion. So they'll move towards the charge, they'll move away from the charge. There is no specific direction that you have to use your vector laws. Reason is that they are scalar quantities. Correct. So according to Coulomb's law, when we are talking about Coulomb's law, it tells us about the electric force between the 2 point charges. So suppose charge 1 is present, this is Q1, charge 2 is present, Q2. And both of these charges, they are separated by a small distance, that is R. Fine, this is the separation. What does Coulomb's law say? Firstly, it says that 2 points you have to remember in Coulomb's law, and that's sufficient. Firstly, it says that the electric force, this is directly proportional to product of magnitude of both the charges. Product of magnitude of both the charges. Yes, Mariam, one question for you. What is meant by magnitude?
Yes, ma'am.
Magnitude, what is meant by magnitude, Mariam?
The value.
The value, exactly.
Yeah.
Without the signs, excluding the signs, whether it's +3, let's say velocity is -3 meter per second. Magnitude will be 3, whether it's minus, plus, whatever. Magnitude means the number. Similarly, when we are talking here also, this means that we are talking about the magnitude of both the charges. So you will take the magnitude of Q1, you will take the magnitude of Q2. Whether they are positive charges, they are negative charges. We know both the charges exist, so we'll just consider its magnitude and their product. This is the first point. So electric force is proportional to firstly this product of magnitude. Remember this, why? Because you will be having negative charges also. See, this means that if I am talking about one charge is -4 Coulomb, another charge is let's say plus 4 Coulomb. So product of magnitude, this is 4, this is also 4, multiply them, that will give you 16. That's it, not minus 16. Otherwise, if mathematically we are calculating it, that can come out to be minus 16, but we are not taking it. All right, so this is what is meant by product of magnitude. The first point was this one. What is the second point? Now, second point is very much similar to your gravitational law. What was there in the denominator in your gravitational law? Separation between the masses. So second point says that electrostatic force is inversely proportional to the square of the distance between them. This is inversely proportional to square of separation between the charges. This is also known as inverse square rule. One more law that was your inverse square rule was that gravitational force, right? Remember G m1 m2 divided by r square. Here also this is K q1 q2 divided by r square. Everything is same. So this follows inverse square rule. Inverse square rule means this inversely proportional to separation. So F is directly now proportional to what? Electric force is now finally proportional to what? It is proportional to product of Q1, Q2, their magnitudes product, divided by the square of the separation between these two. So Q1, Q2 divided by R square, right? So if you have Q1, Q2 divided by R square, then how do we write what is the constant term here? That is K Q1, Q2 divided by R squared. And what is K? If we are talking about here, what is K when we are talking here? K is the 1 over, we have this as the, let me write it. Look, K we write it as, this K is 1 over 4 pi. Till here it must be clear to you. This is a constant K. I'm coming to this back. What is the value of this K? 1 over 4 pi. Easy. One new quantity you have is epsilon naught. I'll discuss this. Epsilon. So this is 1 over 4 pi epsilon. And the entire value, when you solve this 1 over 4 pi epsilon naught, the value of this K is 9 into 10 to the power 9. All right, Newton per Coulomb. This is it. So how do we write the final force? Final force K is written as 1 over 4 pi epsilon naught. Charges Q1 multiplied to Q2, and in the denominator you have R square. Now come to this. What is meant by this? This is something new. You have not done this previously. Because that time capital G was a very easy term to remember. That was universal also. This is a huge difference. This is not universal. Capital G in that formula of your gravitation, that was G m1 m2 by r squared. That G was universal constant. Anywhere in the universe, you can use that formula. You get the same value. Here, this epsilon naught or this K is the constant which is coming. This is the constant term, dielectric constant we call this. We'll see here. So this is the dielectric constant. This depends upon material. It's a material dependent property, so it will be depending upon the materials. Now, if I take two charges and I have calculated the force between them, suppose it is coming out to be 5 coulombs, 5 Newton. SI unit is the same as that of force, that is Newton. In CGS, you have dyne. So suppose two charges I have taken, this is coming out to be 5 Newton. Then I take both the charges and I dip them in water. And then I calculate the forces of attraction. Then I'll notice that the force has decreased somewhat. Now the value is 3 newtons. Fine. The value is now 3 newtons. Now I have taken those charges and now I have dipped them in oil. And now I am calculating the force. I am seeing it is 3.5 newtons. So see, depending upon the materials, depending upon the medium, the values of forces are changing. The first value of force was something else, second value of force was something else, in the third medium, the value of force was something else. Clear? So this dependency of the force with the medium, that is regulated or governed by this quantity, which is known as permittivity. See, when we are talking about this material, this symbol, this is simply permittivity of the material. Permittivity of the material means, what is the permittivity means? It is permitting the force to be present in that medium. This quantity is regulating. This is different for different media. Then that's how your force is changing. Otherwise, your force wouldn't have changed. Charges are same. Separation between the forces is same. So why are we getting different values? Why are we getting different values? Because permittivity is different. For different medium, permittivity's value is different. That's why. So what value you have to remember? Second thing. Firstly, 1.6 into 10 to the power minus 19. That is the electronic charge. Second, permittivity for air or vacuum. Air, we say air or vacuum, free space. The common term used is free space. This is 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. This also you have to remember it by heart. Electronic charge, second, epsilon naught. So one more formula is also added now. F is equal to K Q1 Q2 by R square. One more formula we saw yesterday, that was Q is equal to NE, right? So this is absolute permittivity. Absolute permittivity means we are talking about the permittivity of air, only of air. So now see, K is equal to 1 over 4 pi. Pi is 3.14 epsilon naught. That is 8.85 into 10 to the power minus 12. When you will solve this, then only you will get 9 into 10 to the power 9 Newton meter square per Coulomb square. Understood? So I'm repeating. What is epsilon? Epsilon is the dependency of the material with the force. How force and material both are changing. That is meant by epsilon. Understood? So that is meant by epsilon. So when we are talking about the permittivity of free space, that is when we are talking about one specific, that is your air. When we are talking about the permittivity of free space or air, that means one specific quantity or value that you have to remember. That is 8.85 into 10 to the power minus 12. Now, K is equal to 1 over 4 pi epsilon naught. That is just the constant. This is just the constant term. So, F is equal to K. And what is the value of K? 9 into 10 to the power 9. Q1, Q2 are the two charges. R square is the separation between them. First, tell me, is it clear till here? Do you want to ask anything in Coulomb's law? This is the Coulomb's law, entire.
Ma'am, what is the unit of
Of
epsilon? Permissivity, ma'am.
permittivity, Coulomb
Yes.
square per Newton per meter square. Coulomb square per Newton per meter square. This is calculated like this. F is equal to K Q square by R square. Like this we have. And K can be written as 1 over 4 pi epsilon naught. So everything is constant. This is constant. This is constant. So epsilon naught will ultimately be equal to Q square divided by FR square. Then the dimensions of Q, if you put this becomes C. This is Coulomb square. This is per Newton meter square. This All right, Coulomb square per Newton meter square. Any other question regarding this? Anyone? Because this is an important law, very basic law. You have Coulomb's law. Okay, write down in between if you have any query, just ask. Just text done, all those who have completed. We all have completed by now. Let us see the properties of Coulomb's law. So Coulomb's law is valid for point charges or spheres. These two only. So if 2 point charges are given to you, separation between these two is mentioned. Q1, Q2, Coulomb's law is applicable. Or properly, if 2 spheres are mentioned, having charges Q1, Q2, some separation between them, then you can calculate, you can apply Coulomb's law over here. Second, this says that valid if both the charges are static, means if both the charges are at rest. That is easy to understand, both the charges are at rest. Or at least one of them is at rest. What is meant by this is circular motion. See, this is plus Q1. If this is at rest, other, how will it move? Only possibility is that it can move in circular motion. If it moves in some other motion, then the charges will not be in contact with each other. So the contact, not in contact means the force will not be exerted on both of these. So if one is static, other has to be in circular motion around it. Then only, no, if other one is moving, one is at rest, then we have electrostatic force present. So it's like this Q2, this covers the circular motion. But one condition is needed over here, mandatory. That is, if the separation between Q1 and Q2 should remain the same. That is, the radius of the circle should remain the same. Because if radius also keeps on expanding, there is no point of circular motion of the charge. Circular motion is being performed so that both of them are at rest. So distance between the charges should be static. Distance between the charges should be constant. All right. And last, this says that conservative forces means Coulomb's law is a conservative force. Conservative force, non-conservative force, you have already done in your work, energy and power in your class 11th. So conservative forces, they are independent of the path traveled. That is, it just depends upon the initial position and the final position, not the path, how the path is being traveled. And it's a central force. Central force means if this is Q1 and this is Q2. So it always acts on the line joining their centers, either here or here. That is line joining their centers on the axis only. It will not occur here or here. All right, one question also I'll give you right now. Just let me know what's the force coming, but before that, quickly write down the properties. 4 properties are there, very easy. Properties of charges, those properties are more important for your exam. These are just 4 properties. Write it down. Yes, answer Harsha. What is the force you're getting? Other See, when we are calculating the force here, you have two charges present. When we are talking about Q1 and Q2, Q1 is 2 microcoulombs. You have to convert 2 into 10 to the power minus 6 coulomb. Similarly, Q2, this is minus 3 millicoulombs. So we always the mod because we have to find out the magnitude. Now F is equal to K Q1 Q2 divided by R square. What is the separation between them? What is R? R is 3 millimeter to 10 to the power minus 3. Once you value F is K 9 into power 10 to have Q2 as 3 into 10 to the power minus 3 divide R square. So this becomes 9. 9 will be cancelled. Let me power 9 into 2 into 10 to the power minus 6. Or this will become 6 itself. Some my voice is lagging. Is it better now? It's better?
Yes, ma'am.
Oh, okay. So 9 into 10 to the power 9, 2 into 3, this is 6 into 10 to the power minus 9. Then we have divided by 9 into 10 to the power minus 6. 9 will be cancelled. So this will be force is equal to 6 into 9 will also be cancelled. This becomes 10 to the power 6 Newton. Very easy formula based questions. Write it down. class. So only Harsha has answered it correctly. See, two charges are given to you, Q1 and Q2. Both of them are separated by R separation. So when we are calculating their force, F is equal to K Q1 into Q2 divided by R square. Now this is saying what? They are, the magnitude of both of them is doubled. That means this becomes 2Q1, this becomes 2Q2. So K is there, instead of Q1 we have 2Q1. And this becomes 2Q2, right? And what about the separation? Separation is half. That means if it was R initially, now this becomes R by 2. So we have R by 2 whole square. This was the formula. This was initially. And this is the condition that is given finally. Right? So how can we write this? This is K into 4 Q1 into Q2 divided by R square. Again, this 4 will go up. Right, there is one more 4. Yes, R by 2 whole square is what? R by 2 whole square is R square by 4. So this 4 will also go up. So this becomes 16K Q1 Q2 by R square. Now this is, let's say F, this is F dash. So we have the value of F dash. Now if you take the ratio between F and F dash, look, if you have F is equal to, my voice is coming now. F is equal to K Q1 Q2 divided by R square. F dash, this is 16K Q1 Q2 divided by R square. So when you take the ratio K Q1 Q2 K Q1 Q2, so 6F dash becomes 16 F 16 times. Write it down. Just text done once completed. Class, just tell me one thing in the chat column. When are your summer vacations starting? Roughly, I'm not asking the exact date. Roughly, like in the month of June, July, August. Roughly, if you have any idea. Harsha, Rishita, Sidra, Mariam, Yaya. Sidra, June 20th. All right. Mariam, July, August. End of June, Harsha. 28th जून से 24th अगस्त हो गया रिश्ता का. ठीक है, और कोई? Yaya was left. Yaya, your vacation, any idea? So mostly you all have your vacations commencing from the end of June and till the end of August. In the month of July you have. So in the month of September your schools will reopen. All right, class. Thank you so much. You can appear for your after class assessment if you have. I don't think so you have after class assessment today. Let me just confirm once. Wait.